Alright, in this video I'm going to talk about some algebra stuff, mainly evaluating numbers raised to fractional exponents. But before I do that, I want to remind you just kind of some basic rules where the exponents are actually whole numbers. So the first one says if you have like bases being multiplied, remember you add the exponents. So x squared times x cubed is x to the fifth. If you have things in parentheses, x squared cubed, you multiply the two numbers and get x to the sixth. If you have a negative exponent, you can write it as 1 over x to that positive exponent. Likewise, if this was in the denominator, you could put it in the numerator instead. If you have division, well, multiplication becomes addition. Division becomes subtraction, so x to the 10th over x squared is x to the 8th. And lastly, you can convert from a fractional exponent to a root with a power on it. With a root of a variable with a power on it, I should say. So it says if you have x raised to the fractional exponent of a divided by b, that's equivalent to having the bth root of x raised to the a. So let's do a few problems here, see if we can't make some sense out of that. So I'm out of my favorite non-lined paper, but what can you do? So let's evaluate 8 raised to the 2/3 power. Okay, there's a couple different ways you could do this one. The way I'm going to think about this is I'm going to actually rewrite this as 8 raised to the 1/3 quantity squared, because if I multiply 1/3 and 2, I do get my exponent of 2/3 right back. I can now use my property that says if you have a fractional exponent, it says the number that's on top goes underneath the root. The number on the bottom is the index of the root. So I could actually write this as the cube root of 8 to the first power, and that's still being squared. Well, the cube root of 8, that means I need a number so that if I multiply it by itself 3 times, I get 8. Well, 2 times 2 times 2 gives me 8, so the cube root of 8 is just 2. And I still have to square this, though. 2 squared is 4. So 8 to the 2/3 is just a fancy way of writing the number 4. So let's do some other ones here. Suppose I have negative 16 raised to the 3/4 power. Okay, so for negative 16 raised to the 3/4 power, one thing you want to be careful about is what this really says is negative. You should think about this as being in parentheses. The 16 is being raised to the 3/4 power. The negative is not. Again, I'm going to do the same thing as before. I'm going to write this as 16 raised to the 1/4 power, all cubed. My negative is still out front. Well, this time, if I'm raising it to the 1/4 power, that's like taking a 4th root of 16, and whatever number I get there, I'll cube it. So now I need a number times itself 4 times that gives me 16. Well, you can actually check that 2 works again, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So that cubed. Again, you do the cubing part first. So 2 cubed is 8. I'll tack on my negative and end up getting simply negative 8 as my solution. So suppose we have negative 9 raised to the 3/4 all squared. There's a couple different ways that you could do this problem. Now we have to be careful, because when things are being squared, you could think about the inside as being negative 1 times 9 raised to the 3/4 squared. And when you have things inside of parentheses being raised to a power, what that means is both of those things get raised to that power. So I could break this up as negative 1 squared and 9 to the 3/4 quantity squared. Well, negative 1 times negative 1 is just positive 1. I'm going to use this property that if things on the outside, if I have a power raised to a power on the outside, I can multiply. So I've got fractions, 3 over 4 times 2 over 1, that'll give me 6 divided by 4. So I've got 9 raised to the 6/4 power. Well, 1 is not going to affect the value, so I'm going to stop writing it. 6 over 4 reduces to 3 over 2. And now I'm going to use the same trick as before. I'm going to write this as 9 raised to the 1/2 raised to the 3rd power. Well, 9 to the 1/2 is the the square root of 9, all cubed. The square root of 9 is going to be simply 3. I still have to cube that number though. So 3 times 3 is 9, times another 3 will give us simply 27. Okay. Suppose we have, as another example, suppose we have 27 raised to the 5/6 power times 27 raised to the -1/6 power. Alright, in this example, you could try to do the same thing we did before, but now since I have like bases, I'm actually going to add these exponents. I think that'll be an easier way to get started. So if I add my exponents, I have 5/6 minus 1/6. That's going to simply give me 27 raised to the 4/6 power. And I'm going to do the same thing as before. I can reduce that fraction and make 4/6 into 2/3. And again, I'm going to write this now as 27 to the 1/3 power squared. Well, 27 to the 1/3 power, again, that means you have to find the cube root of 27 squared. So I need a number times itself 3 times to give me 27. Well, you can check that if you take 3 times 3 times 3, that'll give you 27. We still have to square that number, so that 3 squared is simply 9. And that'll be my value. Alright, suppose as maybe another example here, I have 8 to the -1/3 plus 27 raised to the -1/3, and all of that squared. Okay, so you can't really combine the 8 to the -1/3 and the 27 to the -1/3. So what I'm going to do is, you have to be careful too, you can't just multiply both powers by 2 because now there's addition on the inside. So you could FOIL it out. You could make another set of parentheses with an 8 to the -1/3 plus 27 to the -1/3, but that seems really tedious to me as well. So the first thing I'm going to do is I'm going to rewrite, I see, well, this is a negative exponent. I can actually rewrite this as 8 to the +1/3 power. I have 27 to the -1/3. I can write that as 27 to the +1/3 power if I put it in the denominator of my fraction. Again, eventually this is all going to get squared. Well, 8 to the 1/3 is the same thing as the cube root of 8. 27 to the 1/3 is the cube root of 27. And again, at the end, that all needs to get squared. I left my cube root out on my 8 there. Okay, so the cube root of 8 is 2. The cube root of 27 is 3. So this is looking better. We're almost there. I've got to get common denominators on the inside to add my fraction, so the least common multiple would be 6. So I can multiply top and bottom of the first fraction by 3, top and bottom of the second fraction by 2. Now on the inside, I'll add the top. I'll get 5. I leave the bottom alone, squared. And when you have a fraction in raised to a power, you can take the top thing to that power, the bottom thing to that power. 5 squared is 25, and 6 squared is 36, and that'll be your solution. So I hope this fractional exponents and numbers is helping you out here. If you have any questions or want to see some more examples of these, send me an email. I'll be happy to do so.